And go live.
Okay.
Go live anyway. Go.
Hi, everyone. Sorry for the late start, but I'm super excited to be here to talk to you guys about the cow eye. My name is Gabby with Arizona Science Center, and thank you again so much for joining us for our 1 p.m. live. So what we're going to do today is we're going to talk about the eye by dissecting a real cow eye and comparing it to how our eye looks. So a few things before we start. Start thinking about what shape our eyes are. What do our eyes do? What do they help us see? How do they work? So I have a golf ball and a marble right here. Which do you think is the size of our eye? Is it the golf ball? Is it the marble? It's a little tricky, but our eye is actually going to be the size of the marble, and the cow eye will be the size of this golf ball. So this is a real dissection. I'm going to switch it on over to my camera below. If you get a little queasy, I won't be offended if you look away. We'll switch this on over. So our size comparison is a little tricky because our eye is the size of a marble, but it's surrounded by loads of fat and muscle. So this here is the front of the eye, and this light pink and red is the fat and muscle that helps hold our eye in our head. So this light pink is the fat, and this dark red ring that you can see are the optic muscles. So we have 6. We can look up, down, side to side, and roll our eyes. Cows only have 4, so they can only look up, down, and side to side. Now, if you're near anyone in your house, you can take a quick look at their eyes next to you and try and find the whites of their eyes. Can you see that there? Or even if you have a mirror, take a look in a mirror yourself. So the whites of our eyes is called the sclera. I'm just cutting a little bit away so that we can see some of the sclera. It's covered by the fat and muscle. That's what helps move our eye around in our head. So as you can see, this that's we're kind of getting to here, that's the sclera. That's the whites of your eyes. Now the front layer of your eye is called the cornea. This is really thick in cows because what do cows eat? Cows eat grass. So their head is down in the grass. Their eyes have to be really protected to help keep their vision sharp. Now, once we cut into the cornea here, you're going to see all the contents of the eye come out. The eye is essentially a giant water balloon, and without the internal contents, it's no longer nice and round. So you might see some stuff start to come out of our eye here. The liquid part is called aqueous humor, and that helps our eye stay nice and round. You can see as we're cutting through it, it's losing most of its shape, and it's no longer that nice uniform round size. When we see with our eyes, it needs to be pretty round and perfect in order for light to hit the back of our eye correctly. All right, here we go. So as you can see, without all the main parts of our eye, it's very flat, very squishy, not so good for vision. This here that kind of looks like an egg is called the vitreous humor. This right here is made of water and proteins, and this also helps give your eye shape. If you can see these little black rings, these are called ciliary bodies, and those help push and pull on your lens. So if you ever tried to read something really small, you can feel your eye straining. That's those pushing and pulling on your lens. And your lens is like a magnifying glass. So that's this here. You can see it's pretty perfect and round. The light's a little shiny. Let me see if I can turn it off so you can see it a little bit easier. Now that lens helps you see fine detail. As you can see, it's clear to help you read. And if you put it over text, you can even see that it essentially zooms in. So this helps your vision and brings light to the back of your eye as well. Now, if you're looking into someone's eyes next to you or maybe your own, go ahead and take a peek and try and see what color eye you can find. Do you see blue eyes, green eyes, brown eyes? Most of us have brown eyes, and that part of your eye is called the iris. Now, the iris usually sits on top of this, but now that we took it out, It's attached to the very back of the eye, and it should come out in a nice round circle. So I'm going to gently pull out the iris. Now your iris is a big muscle. I'll put it on the back of my glove here so you guys can take a look. What do you notice about the iris? What color is this? So if you said black or brown, you are correct. Cows usually have very dark eye color, and this helps protect their eye from light. So it's able to prevent so much eye from absorbing into, or so much light from absorbing into the eye. If you have green or blue eyes, you might be a little less protected from the sun, so you might need to wear some sunglasses outside. Now, we have our iris here. What's in the middle of your iris? Can you find the little black dot in the middle of your eye? So that little black dot is called the pupil. But do you guys see the pupil anywhere here? It doesn't really look like we have a little black dot anywhere. And that's because our pupil is not actually a black dot, it's a hole. So right in the middle of the iris, see how you can see my glove through there? This is actually your pupil. Now your iris is a huge muscle that opens and closes to let light into your eye. And light is really how all of your vision is made and gets sent back to your brain. So you can do an experiment if you're in a dark room. So take a look at your eyes, turn on the lights really fast, and you can see your pupil dilate. You can see it change shape. So it gets smaller when there's lots of light outside and bigger when there's lower light, like at night. That helps you get different amounts of light in your eye to see what's going on. So now that we've talked a little bit about the front and middle of the eye, I'm going to make a little incision here and cut through our eye so we can see the back of the eye. Now, the back of our eye is really where all of the information is starting to piece together to get sent to our brain. The front of your eye, you'll get sunlight that enters through that cornea that we initially cut through. That gets sent through your lens. Your iris will open and close to allow different amounts of light through your pupil. And then that's going to end up at the very back of your eye to give different amounts of light that will send messages to your brain and tell you what you're seeing. Now, everything we've talked about so far, we have in our eye as well. We have pretty similar eyesight to cows. But there's going to be one thing in the back of the eye that we do not have. So we'll continue cutting through this. Again, this is very thick. It's almost like a tether ball. This is really helping protect the eye, keep all of your important optic pieces intact so that you can have good vision. All right, so once light gets to the back of your eye, it needs to go to something called the retina. You guys ever heard of the retina before? So the retina is kind of a goopy mixture. It's not very solid, which is different from what I thought initially. If you can see this string that I'm pulling off and you can see it connects back to one point in the eye, this is the retina. Now your retina is filled with loads of eye cells called rods and cones. And these special photoreceptor cells are what help send messages to your brain and tell your brain what you're seeing. Now, rods help you see in low light conditions. They help in motion. Cones help with bright light and color. So I always remember it. You eat ice cream cones during the day, bright light. You see hot rods like the cars at night, low light motion. Now, all of that connects to one spot in the back of your eye called the blind spot. Now, this spot is called the blind spot because light can't hit there because that's what's connecting to your retina. Now, before we get to the very, very back of our eye, there's one thing that I wanted to point out. Can you see that shiny, shimmery color? Let's see if I can turn off the light. So you can notice there's this blue-green layer in the back of your eye. This kind of reminds me of the ocean or a pretty rock or a scale. So this is something that we don't have in our eyes. This is called the tapetum lucidum, and that's a special layer that helps a lot of animals and other organisms reflect light to the front of their eye to see in low light conditions. So this is just a thin layer that sticks on the back of the eye, so you can kind of actually peel it off. And we don't have this layer in our eye. We don't quite need the same kind of light and low light conditions. So if you have a pet at home, this is another experiment. You can shine a flashlight in their eye when it's kind of dark, maybe a cat or a dog, and you might see it reflect green back at you. That's this layer reflecting light to the front of their eye to help them see in low light conditions. If you've ever heard of red light flash, when we take a picture of ourselves, that's because we don't have this layer in the back of our eye. So we're just kind of seeing the kind of dark spots back here, the blood that's flowing through our eye, and all of that jazz. Now, how in the world does all of this information in our eye get to our brain? In the very back of our eye, right where our retina connects, we have something called the optic nerve. Now, this one, the nerve was cut right at the end, but this little nub is the beginning of our optic nerve. That's super thick. So this optic nerve is what sends the messages from your eye to your brain. It's filled with thousands and thousands of nerve endings. And we can actually even, I think you can squeeze what's left here. And you see that kind of white goop that came out? That is called myelin. And that helps cover each and every one of those nerve endings. Now this goes to your brain, connects right back, and again, formulates those messages that your eye is sending. It tells your brain, oh, this is light. This is what we're looking at today. We're watching a really gross, really cool eye dissection. So that's what's sending all of those to the back of your eye. A few more kind of fun features for the eye of any eye problems that are pretty common. I actually have a cataract. So if you've ever heard of a cataract before, it creates some blurry vision. And that's this lens here becomes a little bit cloudy. So that deters how much light's going into your eye. If you have astigmatism, that's also kind of blurry vision. That's either a deformation in this layer here or this lens as well. And then nearsighted and farsightedness is the shape of your eye. So whether it's really long or really short will change how the light's hitting the very back of your eye there. All right, everyone. Well, that's the main parts of the eye. Thank you so much for joining us on our eye dissection and our journey. If you have any questions, go ahead and comment them if you'd like. And I really appreciate you guys checking it out. Make sure to check out us on our website or on Facebook for more awesome live videos and experiments and content. And have a great day.